All right, you guys. We just have some basic rules of probability today. Most of these should be familiar to you. Some of them may not be. So first of all, the sample space, called just capital S, of a chance process is the set of all possible outcomes. This could be huge, or like an example of if I just roll one die, then my sample space is every possible outcome, and you do it in brackets, 1, 2, 3, 4, 5, 6, right? If I roll one die, I could get a 1, 2, 3, 4, 5, or 6. So you just list all the possible outcomes if they ask you for the sample space. Okay, what is a probability model? So a probability model is a description of some chance process that consists of two parts. So you should have both the sample space, so what all your possible outcomes are, and then you would list the probability for each outcome. So it could be in a table of some sort. So maybe I have my probability model. I could get a 1, a 2, a 3, a 4, a 5, or a 6 for my dice. And then I'd have to list the probability of that. So maybe I label this event A, and then this would be P of A, the probability of it happening. Well, what's the probability of rolling a 1? 1/6. A 2, 1/6. A 3, 1/6. 4, 1/6. A 5, 1/6. And a 6, 1 out of 6. All right, so that would be a probability model if you list all your outcomes and the probabilities that go with those. And it might be in a table. It's usually how we see it, okay? You all off topic. Okay, you guys, so roll the dice. What if we're rolling 2 dice? You guys did this back in pre-algebra, so this should be pretty easy. Many board games involve rolling dice. Imagine rolling 2 fair 6-sided dice. One that's red and one that's green. Give a probability model for this chance process. So remember when you guys drew this little table for the sum of 2 dice? And you were like, I could get a 1, a 2, a 3, a 4, a 5, or a 6 with my red dice, and a 1, a 2, a 3, a 4, a 5, or a 6 with my green dice. So the lowest sum I could get is a 2, and the highest sum I could get is a 12. And you filled in all these numbers by adding them. Do you guys remember doing this? 3, 4, 5, 6, 7, 8. Okay. And you can fill all that in. So anyways, suppose we define the event A as sum is 5 of rolling those 2 dice. Okay, what's P of A? So we write, what is the probability of A? Or what's the probability of a sum of 5? The probability that event A occurs. So again, you draw your little table out, or you look, they did one for you here. So here I got a 5, a 5, a 5, or a 5. What is that probability, you guys? 4 out of 36. Good. There's always 36 possible outcomes with the sum of 2 die. All right, now consider event B. The sum is not 5. There are 2 ways to do this, right? You could add up all the not 5s, or what would be a better way? Subtract from, 36 over 36, or 1 minus 4 over 36. So if it's not 5, your chances are 32 out of 36. Okay, you actually don't have to reduce in statistics, but if you do, you're not wrong or anything, okay? Neat. What's P of A plus P of B equal to, you guys? It's equal to 1. So 4 out of 36 plus 32 out of 36 is equal to 1. Neat. Okay. What is the probability that we get a sum of 5 or 6? So in probability talk, usually or means we do what? We add our probabilities together, okay? What is the probability that we get a sum of 5 or 6? Well, what's the probability of getting a sum of 5? We just said that was 4 out of 36. Plus, what's the probability of getting a 6? 1, 2, 3, 4, 5 out of 36. Which gives us 9 out of 36. I would write these down, maybe not the entire sentence. Some of these I know you know. I would still write them down anyways, okay? All possible outcomes together must have probabilities that add up to 1. Okay, this is how you check if a probability model is legitimate. And they will ask you this a lot on like a multiple choice test. All right, it's really easy if you know all I have to do is add up all the probabilities and make sure they equal 1. Okay, so all the probabilities must add up to 1. And I would probably write that they're going to ask you if it's legitimate, that lovely word. Then you just check that they add up to 1. So that probability model where I had you just roll a dice and every probability was 1/6, you just check that a 6 plus 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 a 6 is 1. Right? And sometimes they will give you ones that don't add up to 1, and then you know that's not a real probability model. All right, you definitely need to write this one down. The probability that an event does not occur is 1 minus the probability that the event does occur. So we just did not a 5, right? Or not a 4. What's the probability of not rolling a 4? And we did 1 minus that. Okay? You want to know that this is called the complement rule. So in statistics, complements add up to 1, not 90 degrees. Okay? And you need to know the notation for it. So not A, you can write as A with a C up here, a little C up here. So the probability of not A happening, that's what that A complement means, is equal to 1 minus the probability that A happens. So just like our probability of not rolling a 4 is 1 minus the probability of rolling a 4. Okay, if two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. So again, one or the other. As long as there's nothing in common, you're allowed to add the probabilities together. So how do we know there's nothing in common? If there's nothing in common, they're called mutually exclusive. And this is also really important that you write down. So two events, A and B, are mutually exclusive, also known as disjoint, if they have no outcomes in common. So they can never occur together. And another way we define mutually exclusive is the probability of A and B equals 0. And meaning they're happening together or at the same time. So there is no overlap. And we'll talk about some examples here in a minute. All right, and this last part just says if A and B are mutually exclusive, then the probability of A or B is just the probability of A plus the probability of B. So it's a simple formula if they're mutually exclusive. So are the following events mutually exclusive? Drawing a king or an ace from a deck of cards. So can a card be both a king and an ace at the same time, you guys? No. So are they mutually exclusive? Yes. All right, there's no overlap. You're either a king or you're an ace. How many kings are there, you guys? And how many aces are there? So we could just add them together if we needed to, right? Okay. Getting a white ball or a red ball from an urn of white and red balls. Are those mutually exclusive? Yes, you can't get one that is both, according to this problem. We don't have balls that are both red and white, so they are mutually exclusive. And again, you could add your results then. All right, getting a number multiple of 3 and divisible by 2 when a dice is thrown. So again, just one dice. That's my possible outcomes. So are these mutually exclusive? A number multiple of 3 and divisible by 2. Do we have a number up there that you can do both to? It's a multiple of 3 and it's divisible by 2. So here are my multiples of 3. Is one of those also divisible by 2? Yes. So are these mutually exclusive? No, because this 6 right here is true for both of those statements. So they are not mutually exclusive. Okay, drawing a red card or a jack from a given 52 card deck. So can you be both a red card and a jack? Yep, there's 4 jacks, 2 are red and 2 are black. So are red card and jack mutually exclusive? No, because they can be both at the same time. All right. So an example, distance learning courses are rapidly gaining popularity among college students. Randomly select an undergraduate student who is taking a distance learning course for credit and record the student's age. Here is the probability model. So the 18 to 23-year-olds make up 57%, 24 to 29-year-olds is 17%, 30 to 39-year-olds is 14%, and 40 or over is 12%. Show that this is a legitimate probability model. So all you need to do to check that it's legitimate is add up 57%, 17%, 14%, and 12% and make sure it equals 1. Yes. Okay. Find the probability that the chosen student is not in the traditional age group 18 to 23 years old. All right, so probability not 18 to 23 years old. There are 2 ways to do this. Evan, what's one way you could do this? Add what numbers? Yep. So using the complement rule, you could do 1 minus 0.57, right? So if you're not in this age group, then it's 1 minus that, okay, and get your answer. Or you could add up 17%, 14%, and 12%, and those should be the same answers. Any questions? Great. All right, choose an American adult at random. Define the 2 events. A, the person has a cholesterol level of 240 milligrams per deciliter of blood or above. So they are considered high cholesterol if they're above 240. B, the person has a cholesterol level of 200 to 239, which is borderline high cholesterol. According to the American Heart Association, the probability of A, which is the high cholesterol people, is 16%, and the probability of B, which is the borderline high people, is 29%. Explain why A and B are mutually exclusive. So Sergio, why are these mutually exclusive? Exactly. You cannot be in both of those groups, right? You're either 240 or above, or you're under 240. So they're mutually exclusive because there's no overlap. All right, say in plain language what the event A or B is. What is the probability of A or B, like in the context of this problem? Katie, what do you think? Yep, you're already solving it, but you're not doing it in plain English. But yeah, that's what you're going to do, right? You're just going to add 16 and 29%, right? But in plain English, it means the person either has above high cholesterol, right? They're in that high cholesterol group, or the borderline high cholesterol group, right? They're either above 240 or they're between 200 and 239. Okay. And then the last part, if C is the event that the person chosen has normal cholesterol below 200, what's P of C? All right, so if they're below 200, how would we calculate that probability? So Holly, what would you do? So these people are over 240. These people are between 200 and 239. So if you're below 200, how would you calculate that? I would not divide. What do these all have to add up to, you guys? 1. So it's basically everybody that's left over, because these don't add to 1 because we're not including the people below 200. So for the people below 200, we would do 1 minus those high cholesterol people minus those borderline high people, and you would get the remaining people who are below 200. Does that make sense, you guys? Okay, good. They added them together already to get that 0.45.